Okay, so just now we introduced in some reactions for reactants, some reactants may be limited, and some reactants may be excess. So for this kind of reactions, the amount of the product is decided by the limiting reactant. For example, in this case, 1 mole of the iron react with 2 mole of sulfur will only give 1 mole of the product. Only 1 mole. It's not 2 mole. Because the amount of the product is decided by this one. This is the limiting reactant. Okay, question. Calcium carbonate is decomposed by HCl to give this salt and the gas and this water. Now we know the mass of the reactant. Now the question is how many grams of the carbon dioxide? Like in this reaction, so firstly we need to balance this reaction. So after balance, so it means 1 mole of this product we can react with 2 mole of this reactant to give 1 mole product. Like 1 react with 2 will give 1, right? Okay, now we know the mass of this product and also the mass of this product. We need to calculate the mass of this product. So how to do this calculation? So basically, we need to think out which one is the limiting reactant. 1 mole will react 2 mole, but here now it's 10 gram. Okay. Who's 10? Your 10. Yeah? So the first step, think out which reactant is limiting reactant.
So I have to reduce the ratio. Why is it showing this?
What is that?
This one.
That's what it's doing. That's what it's doing.
That one. You can just open the black thing.
This one?
The blackboard, yeah.
This one.
Don't use that one, use the other one.
is eraser.
Value. Down the last one.
So I use this one.
No, they use the same options.
It's showing the funny dots here.
The last option.
This one. This one.
Last option.
Which last one?
Down the last one.
This one.
The left.
Down.
Down.
Last
This one.
one.
That's an eraser.
So
That's an eraser.
Ah.
That's an eraser. That's not a pencil.
Here's a bunny.
your
Do that. Oh.
Zero paper.
You try. No.
So funny. Yeah.
Answer.
What's your answer? I help you look.
Huh? So smart.
Thanks a lot. Actually, that's not all. That's a different thing. See, funny. That's not the shit that I remember. I don't remember what to do with it.
This thing is panicking.
Yeah, that one was funny. Ah, this class is.
Oh no. Like the pencil is like the answers.
Did you see? That explains.
I don't know. This is 18 grams.
Does it drink?
What's
We just have to know it's
hydrochloric acid is the number of moles?
35.
Huh?
Chloride is 35 or 36.
36.
35.5.
No, there are two. I had two more.
So this is for chloride. So it is 36?
36 or 37.
This is
Okay.
37. Okay. 37.
Remember, there are two more.
Which one is the limiting agent?
Yeah, the first one or second one.
Oh, okay.
Calcium.
Limiting, that's the one that finishes first, right?
Yes.
Then excess, that's the one that.
Yes. So which is the first one? It's the first reactant or the second reactant? No, the first one. Calcium carbonate is 0.1, right?
Yeah.
And HCl is 0.72.
This one, so we can also, if I determine the number of moles, is this one with the limiting agent?
Yes, this is limited.
Since I use the number of moles, since this one is producing a number of moles S to 2, then even if I convert the number of moles,
Yes.
so me I think carbon.
Yes, because this is limited because it's 0.1, right?
Yeah.
So it's only need 0.2 HCl, right?
Yeah.
But now the HCl is 0.27.
Yeah.
So the HCl is
Yeah,
excess.
so meaning if you are determining the limiting, so meaning we can use both the ratio or the number of moles, both can make, right?
Now you know the limiting reactor.
Yeah,
You just figure out the more of the product.
the more
The more product is decided by the limiting reactor.
so now I still need to.
Yeah, continue. The question is either get how many more or mass of the CO2.
Or the mass of CO2, oh, this one.
Yeah.
Oh, the mass of carbon dioxide. First, like you're determining the, so it's a process so that you can determine the number of yeah. I thought this was the question. But, okay. So this one is in excess. And this is what
Yes.
limiting. Okay, is there someone who can
The story is in the first row. What's what I did in the first row? You want to go panic like our boy.
No, shall I do this? Okay, since here I got, this is what I think, like, I got the number of moles 0.1 of,
Yes.
of carbon, right? So, and the number of moles is what? 1.
Yes. Why should you want?
Mean if it's 1 as well.
Yes.
So meaning number of carbon
Yes.
dioxide is equal to 0.1.
Yes.
Yes,
Correct.
correct.
That is the case mass. You now get the more number. Now check with the more number to mass.
Oh,
The time is smaller mass.
oh. And that's, yeah, at least I thought this is oh, okay. Number of moles.
Then the number of moles you have found, that's your
Number of moles, that's 0.1. 0.1.
and then the
So
mass
we need
of
the mass, we
carbon,
don't know.
molar mass of carbon dioxide.
That's what
Carbon is
carbon, oxygen is 16 times 2.
44.
So 44. So 44.
Yes.
So it will be 44, right?
Yeah.
And 0.1. That's I think it's 4.1. Yeah, open for graph.
Yes.
Great.
Yeah.
Exactly.
Okay, yeah, okay, yeah. Okay, yeah.
That's my new way to explain anything.
So basically, in this question, we know the mass of the reactant. We need to transfer the mass to mole. So 10 gram, it means for this guy is 0.1 mole. This guy is 0.27. So 1 to 2. So it only needs 0.2. So this means this is excess. So we need to use these guys mole number to calculate the product. So the mole is 0.1. So it will be 1 give 1. So the product is also 0.1. 0.1 mole. So 0.1 then divided by its molar mass. We can get the mass. Okay? So the process like this. So here 10 gram is 0.1, 10 gram 0.27. So this is excess because 1 to 2, but here is more than 2. Okay? So the product mole should be equal this way, decided by this number. 1 to 1, so 0.1 to 0.1. Okay? And then after we get the mole number of the product, we can get its mass. So any question for this? Okay. Now introduce the product yes. So in the previous calculations, 4.4 gram is the amount of carbon dioxide we would expect to be formed. So this mass is the calculated yield or semiotic product yield. This assumes that the reaction goes to completion, and there are no competing facts that may reduce the amount of the product. But in fact, the product may be less than this number. Okay, maybe less than this number. So this is called a percent yield. Percent is the actual yield divided by theoretical yield. In this case, this is like a calculated yield, but the actual yield may be only 4.1 or 4.2. Okay, so the actual yield divided by this calculated yield is called percent yield, actual yield. Okay, percent actual yield. Okay, question, for example. Now we need to calculate the percent yield of iron if 1 gram of hydrogen reacts with 30 gram of FeO and produces 9.5 gram of Fe. It's like the reaction is like this. Okay, and this reaction, this equation is balanced. Now we know the mass of this reactant. We also know the mass of this reactant. We also know the mass of this product. Well, we need to calculate the percent yield. Of course, we need to, if we want to get the percent yield, we need to know its calculated yield, right? Because percent yield means actual yield divided by theoretical yield. This is the actual yield. We need to calculate the theoretic yield. How to calculate is like calculated yet. When we want to get the calculated yet, we need to know which one is limiting reactant. After we know the limiting reactant, we can calculate its theoretic yet. And then we can use this number divided by its theoretic yet to get the present yet. Okay, who's that? You can ask someone of you.
Sit in front.
Percentage yield.
Who assists you? Please, you can go like that.
I mean, people, me, I don't know. Calculate the percentage yield of iron if 100 grams of reacts with 20 grams of iron. Well,
Funny.
Don't be smart.
That's cool, man.
okay. 30 grams of iron oxide plus 1 gram.
Is the equation balanced? Yes, it is.
Yeah, the equation is balanced.
And the number of moles of that's just one element of that.
Number of moles, mass in one, equal to mass, over molar mass. Okay. Now we're looking for the number of moles of iron oxide. 30. 30 over. Iron is 56.
Yeah, that's very
56 plus 56 plus oxygen is 16. 56 plus 16 is 72. Yes. Oh yeah, what's the answer? 30 minutes.
minus.
Divide.
But
0.4.
Okay.
No,
0.4, 1, 2.
4, 2.
0.7.
4, 2.
Okay, 4, 2. Okay. This one. This is 1 over 1. So it's
there are two things. So it's
0.5.
So the limit in here is
This one is the limiting amount.
No.
Oh, this one. Then the next step.
Find the number. Using the ratio is 1 to 1. So the number of moles of iron oxide is the same as the number of moles of the iron. It's 1 to 1.
But is it? So we should say number of moles.
No,
We already have the mass.
yeah, no, that's the actual mass. Yeah, we're finding the theoretical number. That's the mass. So we have to calculate.
So
Theoretic.
0.4,
But you need to find the number of moles of what?
right?
Just use the number of then you can
Equals
get the
to
extent.
X over 19, right?
No, molar mass of
Molar mass.
Mass of
Molar mass of iron.
Or molar mass of iron, which is 56.
Multiply.
Multiply.
Yeah, you took quick maths in your head.
Bruh, this.
That should be 0. 23.52. Exactly. Should be close to half of it.
3.52.
And that
Then
That's the mass. So now find the percentage.
make it 50.
Percentage is equal to actual over theoretical times 100. So 19.5.
Divided by 23.5.
Mine, what's the answer is? You're not even in the calculator.
Good.
Yes.
Okay. Wait.
All of us use
So
this.
you want to explain?
Huh?
Explain.
What did you explain?
No. Let us explain that. These are not the explanation.
So should I wrap? You guys understood? So the first step, you have to find the number of moles for both sides in order to get the limit in the action, right? Then after getting the limit in the action, that's when you see the ratio first. What's the ratio of moles? It's 1 to 1. So you find the actual temperature. The actual mass.
No, the theoretical.
This is the actual mass.
Yeah.
You find the theoretical mass. Then later, that's when you calculate finding the percentage yield. So percentage yield is the actual mass over theoretical mass times 100. You get the percentage yield.
Okay, good, great. Yeah. So any question now you know?
Now that you get them now,
Okay, thank you. Yeah. So basically, we need to find out which one is limiting reactions. Okay, so this case is okay. For industrial process, the first year we should be larger. And, but sometimes,
So you see now the day is this time is
maybe have a good product, yes, but in fact it may maybe low in industry. Okay. Okay, how to prepare a solution? So basically using two ways. The first way is, for example, we want to make this concentration solution. We just we know this is we can use this equipment to prepare, and here this means the volume is 500 meters, and we just weight this mass and then put in the solution, and then we can get the concentration of the solution. This is the first way. We can prepare a solution of no concentration. Okay. Second way is called dilution. So dilution is the process for preparing a less concentrated solution from a more concentrated solution. For example, here we have this solution. So this solution, the concentration is higher, and then we can add some solvent to prepare this solution. So this solution has low concentration. Between these two solutions, M1, this concentration, M is concentration, times the volume should equal to the M2 V2. So why? Because we just add some solvent inside. The solute, the amount of solute doesn't change. So concentration times volume, M1 V1 equal M2 V2. In this case, it means we know we have this solution. We need to prepare this solution. We can use it this way. Okay? We have the solution of M1. We need to prepare the solution of M2. We can just use it this way to prepare the solution of M2. Question. How to prepare 30 milliliter of 0.2 this concentration of HNO3 nitrate from a solid solution of 4M nitrate. What this means? This means we have the solution of this concentration. Okay. Now we need to prepare 30 milliliter of 0.2 this solution. It means, for example, we know the like V2, M2. This is M1, right? We just need to calculate V1. Okay. No, it's all your thing. No. Your turn, yes. Oh, let me check. Oh, you
Bro! I was already there. Hey, that's deep. It's okay. It's okay, guy.
No, that's the wrong.
You can't see.
We can't see you.
Wait.
Can I see? Yeah.
I can see. Oh,
Then the way it's done.
Yeah, good.
We got you.
The answer is 5. 4, 5. Somewhere there. Maybe 4 point something.
3.
3.
The answer is 3.
3.
Wait,
You know, Eliezer, everything I do, I try first with the head. I don't like.
Yeah, I did with the head.
Okay, good. Yeah, can you explain to us?
There.
Actually, this formula is like molarity 1, volume 1 is equal to molarity 2. Yeah, so this volume is volume 2, molarity 2.
Okay, good.
why is your next?
That's you. Right.
Oh.
He was counting this. He was measuring.
Actually, because he used something else. He used the number. Yeah.
So,
Let's give us
how to remove?
No, you can't erase it. You can't.
Yeah.
No, we can't. Okay. Okay.
What do I do?
So his question is like we know, yeah. So just use it this way, we can get the, we can just dilute 3 milliliter of acid with water, and then get the total volume of this guy.
Yep.
We can prepare this solution. Okay. Now, second question is how to determine the amount of iron in the solution. So we can use a different way to determine the amount of iron in the solution. The first way is it's called a gravimetric analysis. So this means the first step, dissolve unknown substance in water, and then react unknown with no substance to form a precipitate, and then we can filter and dry precipitate and weigh the precipitate, and using chemical formula and the mass of precipitate to determine the amount of unknown solution. Like for example, we know we just dissolve the unknown substance in the solution, and then we add a known substance. We get the precipitate of the unknown substance, and then we can weigh the precipitate, and then do calculations to determine the amount of unknown iron. Like this. Okay, we don't know the amount of silver in the solution, but we can get the solidity of the product. And after we get the mass of the product, we can calculate the amount of the substance. The second way is called titration. So in the titration, a solution of accurately known concentrations is added to another solution of unknown concentration until the chemical reaction between the two solutions is complete. So this means when it's complete, the reaction arrives the equivalence point. So the equivalence point means the point at which the reaction is complete. But how to find the reaction is complete? So basically we need to add some indicate in the system. And then, for example, in this reaction, this is the solution we need to determine. And then we put the known solution inside. After it arrives the equivalence point, the color will change from colorless to like purple. When the color changes to purple, so it means the reaction is complete. And we just add some indicator into the system, and then when the reaction complete, the color of the indicator can change from colorless to purple. Okay, so in this case we can see the acid. For example, this is the acid. The concentration of acid and the time volume should be equal to the concentration of base. Here is base, okay? So we know the concentration of base, for example, and we can use it this way to calculate the concentration of acid. So when the reaction is complete, we can get this equation. Okay, have a short break.